In this video, we are going to look at how do we find points of inflection given an equation. So points of inflection are where the second derivative is equal to 0 or it's undefined, and the second derivative changes sign. Now in this class, we pretty much will only deal with the case where the second derivative is equal to 0. So we are going to do an example to show you how to do this. So find the points of inflection of the following functions, then determine the intervals where f of x is concave up and concave down. So the first thing we have to do is we need to take the derivative and then find the second derivative. So for the first derivative, we get 6x squared plus 6x minus 36. And then if I take the second derivative, I get 12x plus 6. So the first thing is we need to set the second derivative equal to 0 to find the possible points of inflection. So I get 12x equals -6 and x equals -6 over 12, which is -1/2, or you can say -0.5. Now, this may be where the point of inflection is, or it may not. We have to verify that it's a point of inflection. The only way that it's a point of inflection is if the sign of the second derivative changes at x equals -0.5. So what we do is we make a sign chart for the second derivative to make sure that our derivative change sign. So you can do either sign chart, but we're going to show the relationship between f double prime and f. And again, I usually just do the number line one for it to be quick. So I'm going to put my place where the second derivative is equal to 0, which is -0.5. And then I'm going to do test points again. And this time I'm plugging them into the second derivative because I need to make sure that the second derivative changed sign. So I'm going to pick some number that's less than -0.5, which we could do like -1. And I'm going to plug that into the second derivative and find the sign. So I'm going to plug it into here, my second derivative. And if I do that, again, I don't care about the value, I just care about if it's positive or negative, and I can see that this is negative. Okay, so that means my function is concave down from -infinity to -0.5. That's this interval. And then I'm going to check a test point in this interval, so something larger than -0.5. So I'm going to pick 0 because that's usually the easiest value to plug in. So I get 12 times 0 plus 6, which is 6, so I have a positive. Okay. And so that means my function is concave up from -0.5 to infinity. And so the second derivative changed sign, which means my original function changed concavity, and this is a point of inflection. So some questions may also ask you, where is my function concave up and concave down? And if they do, we do this sign chart. And then we could say our function is concave up from -0.5 to infinity, and it's concave down from -infinity to -0.5. Now, for our point of inflection, we need it to be a point, not just an x value. So we know the x value is -0.5, but I still have to find that y value. So to find that y value, we want to find the y value on the original function. So I'm going to take -0.5 and I'm going to plug it in to my f of x, my original function. So I wrote my f of x down here, and I'm going to plug in -0.5. And if you plug that in, you get 20.5. And so the point of inflection is negative 0.5, 20.5. And that is how we find the point of inflection. Okay, so let's do one more example. We want to find the point of inflection of f of x equals x to the fifth minus 4x to the fourth. So we do the same thing. We take the first derivative, and then we take the second derivative. And then I'm going to set the second derivative equal to 0. I have to factor this. So the first thing I'm going to do is look for a GCF. The GCF is 20x squared. And then I get x minus 3 equals 0. And then I set each term equal to 0. So 20x squared equals 0 and x minus 3 equals 0. And so I get x equals 3. And then this one would just be x equals 0. So my two possible point of inflections are x equals 0 and x equals 3. But again, I have to make sure the sign changes for the second derivative. So I make a sign chart. And again, if I make a sign chart, I'm showing the second derivative and my original function. I'm going to put my two possible point of inflections where my second derivative is 0 on my number line. And then I'm going to do test points again. So I'm going to pick one point in this interval from negative infinity to 0, my x values. So I'm going to pick -1. I'm going to pick one point for my interval 0 to 3. So I'll pick 1 in that one. And I'm going to pick 1 in my interval from 3 to infinity. So I'll pick 4. And I'm plugging these in to the second derivative. That's the key thing. I'm plugging them into the second derivative. Now, you may use either the factored form or the original. It doesn't really matter. I am going to use the factored form because that one is quicker to do in my head. You may, again, use your calculator and put this into y1 and find it that way as well. But if I plug -1 in, I get 20 times -1 squared, which is a positive. -1 times -3 is a negative. And so a positive times a negative is a negative. And again, that's all I care about. So this is negative and my function would be concave down. If I do f double prime of 1, I get 20 times 1 squared and then 1 minus 3. And I get a positive times a positive times a negative. So I get, again, a negative. So this is negative and it's concave down. And then I do f double prime of 3. Nope, sorry, not 3, 4. And I get 20 times 4 squared times 4 minus 3. And these are all positive, so I get a positive. And so this is important to show the sign chart because what we can see is the only place the second derivative change sign is at x equals 3. And so this is a point of inflection. This is not. This is not anything. So when we say the point of inflection, the only one I'm giving is x equals 3. And then I also have to find the y value. So again, to find the y value, we always use the original function. So I'm going to use f of x equals x to the fifth minus 5x to the fourth. And I am going to plug in my 3, which was where the point of inflection occurs. Okay, and I get -396. And so my point of inflection is -396. And that's the only point of inflection. And then again, some questions might ask you to state where is it concave up or concave down. So if I do that, I have concave up from 3 to infinity, and I have concave down from negative infinity to 0 and 0 to 3. And so that's how you find the point of inflections.